All right, so get ready because today we're going to be diving into something pretty amazing. We're taking a look at Chapter 3 of Roots of Complexity, specifically mother trees. And yeah, I think you're going to find it pretty fascinating.
It is a fascinating topic for sure. Yeah, we're going to be kind of unpacking what a mother tree is, how this idea even came about, and why it really kind of changes everything about how we look at forests.
Yeah, I mean, our mission today is to give everyone listening a clear understanding of, just what makes these trees so unique,
Yeah.
how they help forests regenerate. And we'll even look at some examples of these incredible networks that they form and how they work. I mean, did you know that trees can actually communicate and support each other through these underground networks?
Yeah, it's pretty remarkable.
Like share resources and even warn each other about danger. We're going to get into all of that. But first,
Yeah.
let's start with the basics. What exactly is a mother tree?
Well, the book defines it as a large old tree that plays a vital role in the health and resilience of the entire forest.
Okay, so not just any big tree, but one that's kind of like the heart of the forest.
Exactly. And this is actually a huge shift from how we used to think about forests. It used to be all about competition, survival of the fittest, every tree for itself. But mother trees are really showing us that there's this whole other level of cooperation going on beneath the surface.
Wow, so it's like a whole hidden society down there with the mother trees as the leaders. So how did scientists even figure this out? It's not like trees wear name tags that say, "Hi, I'm the mother tree."
Right. Well, scientists started noticing that seedlings were thriving near these larger trees, even in really tough conditions. And they were like, wait a minute, there's something more going on here than just competition for sunlight.
So it's like those little seedlings had a secret advantage.
Yeah.
And that advantage was being connected to a mother tree.
Exactly. And a lot of it has to do with this vast network of fungi that connect the roots of trees underground. You can almost think of it like an underground internet, only instead of sharing, cat videos, they're sharing nutrients and information.
Hold on. So trees are using fungi to talk to each other. This is blowing my mind.
Yeah, it's pretty wild. And these mother trees, they're kind of like the central hubs in this network. They can actually identify their own seedlings and send them extra resources through these fungal connections, which gives them a much higher chance of survival.
So it's like these mother trees are making sure that their kids are, I don't know, getting the best education and resources.
Yeah.
They're sending them to the best underground schools.
You could put it that way. And it goes beyond just their own offspring, too. Mother trees can support a whole range of species within the forest, creating this really diverse and resilient ecosystem.
Okay, so this isn't just some feel-good story about trees being nice to each other. This is about the survival of the entire forest.
Exactly. These networks are absolutely vital for forest regeneration. Without mother trees, new trees would really struggle to survive, especially when they're facing challenges like drought or disease.
So logging companies that just come in and clear-cut entire forests, they're basically destroying these vital communication networks.
Yeah, it's a major concern. You're not just losing the individual trees when you do that,
Yeah.
but also the wisdom and support that they provide to the whole forest.
Yeah, that's pretty heavy stuff. But I don't know, let's lighten the mood a bit and talk about some specific examples because I'm really curious about this research on Douglas fir forests. What have scientists discovered there?
Well, in the Douglas fir forests of British Columbia, Dr. Suzanne Simard, she's done some really groundbreaking research that really brought these networks to light. And what she found was that mother trees were supporting seedlings of various species, not just Douglas fir, but also western red cedar and paper birch.
So it's not just about protecting your own family. It's about supporting the entire community. That's amazing.
It really is. And it gets even more interesting when you consider what are called hub trees. These are like the super connected mother trees, the ones with the most extensive networks, and they have the biggest impact on the forest.
Wait, so there's like a hierarchy of mother trees? Some are more motherly than others?
I guess you could say that. Hub trees act as these central nodes connecting multiple trees and facilitating even greater resource sharing. They're like the grandmothers of the forest, passing down wisdom and resources to generations of trees.
This is incredible. I'm starting to see forests in a whole new light now. It's not just a bunch of trees standing around. It's a complex society with its own communication systems and social structures.
Exactly. And the more we understand about these networks, the better equipped we'll be to protect and manage these precious ecosystems.
Well, on that note, I think we've covered a lot of ground in this first part of our mother tree deep dive. We've learned what mother trees are, how they were discovered, and how they play a vital role in forest regeneration.
Yeah, we've also touched on the importance of these networks for the overall health and resilience of the forest.
But don't go anywhere, because in part two, we're going to delve even deeper into the science behind these networks. We'll explore the specific mechanisms that allow mother trees to communicate and share resources, and how scientists are studying these underground connections.
It's going to be a fascinating journey into the hidden world of mother trees. Welcome back.
Okay, so in part one, we established that these mother trees are basically running an underground communication network using fungi. It's like a superhighway of nutrients and information down there. But
Yeah.
how does it actually work? Like, what's the science behind this fungal internet?
Well, the key players here are what are called mycorrhizae. These are the fungi that form a symbiotic relationship with the roots of trees.
Symbiotic, meaning they both benefit from this partnership, right?
Exactly. It's a win-win situation. The fungi, they expand the reach of the tree's roots, helping them absorb water and nutrients from a much larger area of soil. And in return, the trees provide the fungi with sugars that they produce through photosynthesis.
Okay, so the fungi are like tiny miners digging up all this valuable stuff for the trees, and the trees are paying them in sugar.
That's a great way to put it. And this partnership is what allows for this exchange of resources and signals between trees. It's how mother trees can nurture their seedlings and share information with other trees in the network.
Okay, so we've got the what. Now let's get into the how. How are these messages actually transmitted through these fungal networks?
Well, you can think of it like a chemical language. Trees can release specific chemicals into the network that signal things like drought stress, pest attacks, or even the availability of resources. And these signals are then picked up by other trees in the network, allowing them to respond accordingly.
So if one tree is being attacked by, like, insects, it can send out a warning to other trees to, like, beef up their defenses.
Precisely. It's like a neighborhood watch program for the forest.
I love that. But wouldn't a shared network also be a risk? Like, couldn't diseases spread more easily through these connections?
That's a good point. And it's true, there are risks involved,
Mm.
but for most forests, the benefits seem to outweigh those risks because the network also allows for the sharing of beneficial bacteria and fungi
Yeah.
that can actually boost a tree's immune system.
Fascinating. So it's not just about sharing resources, it's about sharing defenses too.
Right. It's all about cooperation and resilience. And this is where mother trees really shine. They have the most extensive networks and the greatest capacity to share resources and information.
The book even mentions that mother trees can prioritize their own offspring, like sending them extra resources through these networks.
Yes, it's pretty amazing. They can actually recognize their own seedlings through chemical signals and direct resources specifically to them, giving them a significant advantage in the competitive environment of the forest floor.
Wow. So it's like mother trees are giving their kids a trust fund.
In a way, yeah. But this nurturing extends beyond just their own offspring, too. Mother trees support a whole range of species within the forest, remember, creating a diverse and resilient ecosystem.
This is all just mind-blowing. I'm really starting to see forests as these incredibly complex and interconnected communities. It's not just about individual trees, it's about the whole network working together.
Exactly. And this
Yeah.
understanding has huge implications for how we manage forests.
Right. Like in part one, we talked about how clear cutting disrupts these vital networks. It's like
Yeah.
we're destroying the forest's internet infrastructure.
Yeah, it's a big problem. But there are more sustainable approaches, like selective logging, that allow us to harvest timber while still preserving the integrity of the forest network.
Okay, so let's shift gears a bit and talk about how scientists are actually studying these underground connections. I mean, it seems like it would be incredibly challenging.
It definitely is. But scientists have come up with some pretty ingenious methods. One approach is to use what are called isotopic tracers.
Isotopic tracers. I need a little more explanation on that one.
Sure. Think of it like tagging a specific element with a tracker. Scientists introduce a particular isotope, like carbon-13, into a tree, and then track its movement through the fungal network.
So they're essentially putting a GPS tracker on carbon atoms and following them through the fungal network. That's pretty brilliant.
It is quite clever, and by analyzing where these isotopes end up, they can actually map out the connections between trees and understand how resources are flowing.
So it's like they're revealing the hidden pathways of the forest, the underground routes that these resources and signals are traveling on.
Exactly. Another approach is to use DNA analysis to identify the specific fungal species that are present in the network.
Oh, so they can see which fungi are connecting which trees, and maybe even figure out how different types of fungi play different roles in the network.
Exactly. It's a rapidly evolving field of research, and scientists are constantly making new discoveries about the complexity of these underground connections.
This is all so fascinating. We've learned that mother trees communicate through these fungal networks using chemical signals. They can warn each other about dangers, share
Yeah.
resources, and even prioritize their own offspring. And scientists are using some really cool techniques to unravel the mysteries of this underground internet.
Yeah, and it really highlights the importance of understanding these connections if we want to manage forests sustainably.
Well, on that note, I think we've covered a lot of ground in part 2 of our Mother Tree deep dive. But we're not done yet. In part 3, we'll explore another fascinating way that trees communicate, and we'll delve into the broader implications of this knowledge for how we view forests and our relationship with nature as a whole. Stay tuned. All right, welcome back to the show. So are you ready to finish our Mother Tree deep dive?
Let's do it.
I'm still trying to wrap my head around everything we've learned about these amazing trees. We went deep into these underground fungal networks, and we learned how trees communicate and share resources, and even how our traditional logging practices can disrupt these delicate systems.
Yeah, and now it's time to zoom out a bit, look at the bigger picture and try to understand the broader implications of what we've learned.
Okay, so in part 2, we kind of left off at the idea that forests are much more than just a collection of individual trees. They're complex, interconnected communities
Yeah.
with their own communication networks and social structures.
It's a whole new way of looking at forests.
Absolutely.
Yeah.
So how does this understanding change our approach to something like forest management?
Well, it definitely challenges that traditional focus on maximizing timber production, which often comes at the expense of forest health.
Because clear-cutting, which
Yeah.
unfortunately is still a common practice in many parts of the world. It's like we're wiping out a city's entire communication infrastructure. The remaining trees are just left isolated and vulnerable.
Exactly.
So what's the alternative?
Yeah.
How can we manage forests in a way that respects these interconnected systems?
Well, there are a few different approaches. One is selective logging, where you only harvest certain trees, ideally the ones that aren't acting as mother trees or trees.
So it's more like being a careful gardener,
Yeah.
pruning selectively,
Right.
rather than just mowing everything down.
Exactly. Another really important aspect is protecting older forests.
Because they have the most complex networks, right?
Exactly. Older forests tend to have more complex mycorrhizal networks and a greater diversity of species.
They're like the ancient libraries of the forest,
I
holding generations of knowledge and wisdom.
like that.
And all that diversity is key for resilience too, right?
Absolutely. These older forests have weathered countless storms and disturbances over the years, and their genetic diversity helps them adapt to change.
So preserving those older forests is kind of like safeguarding the forest's immune system.
Exactly.
So this knowledge also has implications for reforestation efforts.
Sure.
Then it's not enough to just plant new trees. We also have to think about how to reestablish those vital mycorrhizal connections.
Right, because those seedlings need to be plugged into the network if they're going to have a fighting chance.
It's like we have to provide them with a lifeline to the wisdom and resources of the older trees.
Yeah.
The book mentioned incorporating soil from older forests or planting seedlings near mature trees.
Those are both good strategies. It's all about creating the right conditions for these networks to thrive.
So it's not just about planting trees, it's about restoring entire ecosystems.
Exactly. It requires a real shift in our mindset. We need to
Yeah.
move away from seeing forests as just, a source of timber and start to recognize their true value.
Absolutely. It's about recognizing the interconnectedness of everything.
Exactly. The health of the forest is inextricably linked to the health of the planet and all its inhabitants, including us.
So what can we as individuals do to help protect mother trees and the forests they support?
Well, I think one of the most important things is to stay informed, learn about these issues, and share that knowledge with others.
Knowledge is power.
Absolutely. The more people understand about mother trees and the interconnectedness of forests, the more likely they are to advocate for their protection.
We can also support organizations working to protect forests and promote more sustainable forestry practices.
Definitely. There are so many amazing groups out there doing incredible work.
And as consumers, we can make more conscious choices.
Absolutely, like choosing sustainably sourced wood products, supporting businesses that prioritize forest conservation, reducing our own paper consumption. These might seem like small things.
But they all add up.
They do. Every action we take, no matter how small, it all contributes to a larger movement for change.
Well said. This whole conversation has been such a powerful reminder that we're all connected. What happens to the forests affects all of us.
It really does.
And the choices we make today, they're going to shape the future of these vital ecosystems.
That's the truth.
This deep dive has really opened my eyes. to the incredible complexity and resilience of these forests and the crucial role that mother trees play in maintaining that resilience.
It's been quite a journey.
I hope everyone listening feels inspired to learn more about mother trees and the amazing networks that sustain our forests,
I hope so too.
and to take action to protect these incredible ecosystems
Yeah,
for generations to come.
couldn't agree more.
Well, that's all the time we have for today. Thanks for joining us on this deep dive into the world of mother trees. We'll see you next time.